Hi there, how are you? Welcome to Maths for Data Science. This is Vivek. So in this second part of the video, we will learn a couple of more methods available in Pandas, specifically related to the custom index, where we create your custom index. And after that, we will learn how can we filter the data in Pandas DataFrame. So let us start with the first part, which is set and reset the index. Before we go further, let us step back and other ways we can create a Pandas DataFrame. So you can use a dictionary to create a pandas data frame. So a dictionary can, as we already spoke in the previous videos, that it is a key value pair. A value can be a list or it can be a string. So here I've given you a couple of examples. If you see that, so I've created a dictionary called people, which is a key as a first, last, and email, and there is a corresponding value. And these values are is in list format. And in person, if you see, so there is a second dictionary, which is person. I have created value as a string. So I'm giving string as input. And here in the third dictionary, you can see the people, the same one here. I am creating a dictionary. So I'm creating this dictionary value as a list, and this list contains only one value. First, let me execute and show to you how you can create a data frame using dictionary. So to do that, first we have a method available in Pandas, which is data frame. So whenever you would like to create a data frame using a dictionary, you can use this particular method. So first let us import the pandas and let us create the dictionary. So now I have imported the pandas and created the dictionary. Now here what I'm doing is I'm saying pd.dataframe. So pd is the alias name of panda, which we have created here, mentioned here. And data frame is an inbuilt method used to create data frames. So just to show you, I'm just running a dir on pd. So here, if you list down or scroll down, you can see there's a method available which is data frame. So the same method I've used it. You can run help on this particular method, and you can see the syntax of this particular method. So let me execute and show it to you. So now I have executed this particular code. So here, if you observe, all the keys are considered as a column names. So here, if I scroll up, see the keys are first, last, and email, and the same thing is considered as a column names. And the list value, so whatever value this list contains, Vishwa, Kalish, and Sai, that is considered as the row data points. So first contain the Vishwa, Kalish, and Sai, the last contains this value. So that's how a dictionary is translated to a data frame. So the next thing we see here in a person, this particular dictionary, you can see here the value is not a list, but it's a string. And if we would like to convert that thing into a data frame, let us see how we can do it. If I run this particular code, I will get an error. Let us see the error, what kind of error it throws. So we scroll down, it says, if using all scalar values, you must pass an index. So what it means is, as you're passing the scalar value, so I'm just passing the string value. So as it's a string value, it's asking me to pass an index. So this data frame method has a parameter called index. So here what I'm doing is I'm giving the first row a particular index. Now if I execute, you got the output. So here I mentioned index as 0. Suppose I'm making index as a 2. So here I got a 2 value. So when you are, so suppose we have a dictionary in which value is a string, then while creating a data frame using the dictionary, you have to mention the index also. Move to the next part. Now we have created a df1 here using the people, and it contains 3 data points. Let me show to you here 3 data points. And suppose you would like to extract the data from this particular column, you can run df and email. You will get the output. Now in some cases you think that this default indexes given by the pandas is not a very valid one, but I need some other column from the data frame act as an index. In that case, in this particular scenario, you can say email can be used as an index, stating that the email might be a unique for each and every person. Plus, if you would like to extract any information So in this particular case, you can use email as an index. So let us set email as an index. So for that thing, we have a Pandas inbuilt method which is called set index. So here you have to, in set index, you have to pass the column name which you would like to act as an index. So let me execute it here. Now, if you see, if I executed it here, this particular email column has, the particular email column became the index. But here we have a small catch. So if I execute df again, if I execute the df again, if I execute df underscore one, you see that there is no change in the df underscore one. Why it is happening? Because I'm saying this set the index to email, and when it does return a new data frame. But suppose you would like to do the changes in df underscore one itself, then you have to use a parameter called in place equal to 2. When you do in place equal to 2, it does not return a new data frame, but it has done the changes in the existing data frame. So let me execute df underscore 1. So now you can see that email column is used as an index. But you might ask a question, Vivek, show me the proof. Run an index command on that to show me that it exactly this email column is the index. So I'm running a df underscore one dot index. Index is an attribute. This index attribute we have already covered in our previous video. That's part 1. So when I execute, see, it has returned the value of index. So yes, email is acting as, now you could see that email is an index rather than the default index. So next thing, after you have created index, you can use that index to search a particular data point or particular row in a pandas data frame. So suppose I would like to understand that I know that we have a support at this match4datascience.com in the data frame, and now we have converted that particular email column into the index. And now I would like to search that this particular email ID belongs to which person. So that I can do it by running this particular command. So here you can see that it's a new way to access the data in the pandas data frame. In the previous video, we learned iloc, which is ILOC, and now we are learning LOC. What is the main difference between ILOC and LOC? ILOC means you use the integers to access the data points or columns, but in LOC you can use the name of the columns to access it. Here, if you see, I have used the last, which is the one of the column name, to extract the data from that particular column. Here, suppose I would like to get the last and first name of a person. So I would like to have both the columns here. So if I execute, I'm getting the last and first name from here. This is how you can use index to get the data. If instead of this particular, if we did not set the index to email, then you can mention here the index number. So by default, it was 0012. You could have mentioned the index number and you could have extracted the data, but keeping the index number default, which is generated by pandas, it's not useful in this case, because keeping email here as an index name would be more useful, because if I know the index, if I know the email, I can directly extract that particular information. So now this is done. Now suppose you're using your pandas, you have created your pandas data frame, and unfortunately or by mistake you have set the index to certain column. So this command, you ran it by mistake. Okay, now you realized I should not change the default index, and I should not make it some other column in the data frame as index. So you can revert it by using the command reset index. So if I run the reset index, if you see here, I have passed the in place equal to true. It has the same effect as I mentioned earlier in set index. So if you don't do in place equal to true, it means it will not do changes into the existing data frame, but it will return a new data frame. If you place in place, it means it will do the changes in the existing data frame from where So let me run reset index, and now you see that again the the email index is reverted back as a column of the data frame, and a default index is generated for this particular data frame. So this is a small, you can say, a snippet to tell you we can use dictionary, and just to let you know that not only dictionary, you can use list also to create a data frame using data frame method. So I would like you to go and explore that particular option by your own. If you face any challenges or any questions, leave a comment in the comment box. So now let us go to our data directly, which we have used in the previous video. That is a Stack Overflow survey data, and we will do the same operations which we have done in the previous snippet, the setting the index, extracting the data out of it, and reset the index. So now I'm loading the data into data frame, which is df and the schema.df. In the previous video, I already told that schema.df contains the information about the column headings. So again, here I'm setting the column size and row, how many rows it should display, the minimum rows. And just to show you, I'm just running the head on a schema to show you what exactly the schema contains. So this Q name column, meta information or main branch, it says main branch means signifies this thing. So this main branch is one of the columns in our survey results public data frame, in which is a DF. So this is the data frame. I just displayed on the top 20 of it. Now let me set an index. So now I'm saying I would like to set Q name, which is this column, as an index for this particular schema underscore df data frame. So let me set it, and here I've used in place, and I told you the reason to use the in place. Here I don't want to create a new data frame, but would like to do the changes in the existing one itself. Here I have done it, and later I would like to extract the data point from the data frame where the index is coding activities, and the output column is the questions column, which is this column. Let me make it a default 5. So I would like to check for index name, which is a coding activities, and I would like to extract the questions, this particular column, for the corresponding index number. So let me extract it. So it says coding activities means, which signifies that which of the following best describes the code you write outside of your work. So this, if you see the coding activities in df, let me print that also. So let me say df, which is a column in df. Now you can see, so the coding activities in the df data frame has this value, and coding activity means or it corresponding to this particular question in the survey. So let me delete this particular cell, and now let me print the schema df to show you the index also. So let me print head, not all. So now here you can see the Q name became the index, and suppose this is not sorted and you would like to sort it. So you would like to sort the index. That you can do using inbuilt method in Pandas, which is called sort index. Even this particular method has in place parameter. So here I'm passing the in place, but if you don't want to overwrite or do the changes in the existing data frame, don't use in place equal to true. So now I did it. Now let me print it again, schema underscore df dot head. Now suppose you would like to find the question which contains the word salary. So that you can do it by saying the schema, because you said you want to see a question, you want to check a question column in which the word salary presents. So this particular part you already aware, and this particular part .str.content, these are the string operations we can perform in Pandas. So I'm saying .string contains salary. So I'm saying wherever you see the salary, so I'm just simply saying in this situation, you just check it wherever salary contains and return a boolean value. And NA equal to false means wherever you see a blank value, just replace that blank value with false. So let me execute and show the output. So this I have taken into one of the filters. So if I filter to, if I print here, you see the output is nothing but a boolean. True, false, true, false, true, false, true, false. Okay, now suppose if I pass this boolean value to the schema, so do you think we will get an error or we will get the output? Just give a thought. So ideally we will get output. So wherever you have the false, that particular rows will be excluded in the output, and wherever you see the true, the rows, those rows will be included in the output. So let me execute. Now here you see you got only one row as an output. It means there is only one row in the data frame where the question has a word salary. So here you can see all the columns. It has nearly 6 columns, which is shown here everything. So now the next question you can ask, that how that is helpful. So in this current scenario, I will tell you how that's useful. Suppose I'm telling you from the data frame DF, there is a column which talks about the salary of individuals who has taken part in the survey, but 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 we don't know which column talks about that particular information. For that thing, we can use this particular approach. Now, if I print a DF here, let me show to you. So if you see DF, it has nearly 84 columns, and skimming through each and every column and checking which column is related to the salary column, it's really hectic task. So for that thing, I will use the schema underscore df data frame to extract that information and try to utilize that information to identify the column which will contain or which might contain that information. So for that thing, first I just created a filter stating that this is the input. So you have to search for a column which has a salary in it, or you have to search a question column and extract the data point which has a salary in it. So that we have extracted. Now you can see, now we have extracted here, we have extracted. Now we have extracted that information which says that this Q name, which is index comp total, has that information. The QID is QID51, and this is the question. Let me expand the question to show you what exactly that question is, because here you have seen that it's cropped. So let me print here. So this particular question, this contains this information: what is your current total compensation, blah 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 blah. And here if you see the salary keyword exists in this particular question. That's why this particular data point is extracted. So apart from the Q name, other columns are not useful in terms of using in the DF. So this I told you, Q name is nothing but the columns we have in the DF data frame. So I need this value. So if I could able to extract this value programmatically, it means I can directly pass this particular code into my DF data frame where I can run some operations on that particular column, and it's very dynamic rather than putting very manually. There's an approach. You just run this. Yeah, now you got comp total as a particular field which contains that information. You can copy it, you can go to DF, and then you can directly search for that particular column. That you can do. Second way, you can do these steps programmatically. Let us do programmatically. So now after getting this output, I can say if I do index on this thing, so let me do it in the next cell, dot index. If I run index on this, you can see that it has written me index, and this index has only one value. If you closely observe, this is a list because it's enclosed in the square brackets. So I can do something like this, right? So that's how I have extracted the comp total index out of this particular output. Now, if I pass this particular information in our DF, let me pass in DF. So if I pass this, will I get the information, the comp total column or not? Ideally, we will get it. So here you see, we got that particular column. Or the best practice is to save it in a particular variable. I can say salary column. Let me save it here, and I will pass this variable rather than the entire code. I will just pass the variable which contains that value. Let me pass it here. So see how useful it is when you can use this string contains option to extract some information. As you have set the index to Q name, I could easily able to extract this particular index, which is nothing but the column in DF data frame. Now, if you see here, you can see these all numbers are shown in the scientific format, scientific notation, and reading such values is a very cumbersome task. So do we have something in Pandas which will convert such notation into a normal number notation? Yes, we do have. If you remember in the previous video, we have spoken about set option. The same set option we can use, and this is the string we have to pass display dot float underscore format. Here I'm telling what should be the format of it. I'm saying it should be a 2 decimal float and format. If I execute it, it did the set in the background, the required format in the background, and if I execute this df sal underscore column again, I get in the normal readable format, not in the scientific notation. So this particular set option is very handy. Sometimes you get the data which is in the scientific notation, so you have to convert into normal human readable numbers format that you can achieve it easily. So now you have used it, you could able to get the particular output. Now suppose you would like to extract or get the people information whose salary is more than $100,000 or 100,000, not dollars, 100,000. For that thing, suppose I'm creating a new comparison which says df underscore here instead of comp total. I will use this sal column which is dynamic and programmatically it changes if required. So I'm saying, so wherever the comp total column contains the value more than 100,000, please validate that column. When I say validate, let me execute and show it to you. So if this particular statement is validated, the output is a true false. So the output is true false. So here you're getting the boolean values, the true or false. So it's validating this particular condition. Now if I take this and run on our df, let me see the output. Now I'm saying, so if I run it here, high cell, okay, I have to run this high cell, I did not execute it. So if I execute it, now you can see that we got the values here. Let me scroll it to the right. So we got the values which are greater than 100,000. So now here nearly 85 or 84 columns we have. Let me say I want only that particular column in the output. So here I'm saying true. No. I think here I'm wrong. I have to pass sal call because I want that particular column as an output, not the true false. Okay, what's an error? Great. So now here we got this error. Why this error occurred? Because I told you if you would like to extract something using the column name, you have to use that .loc. I did not use that. That's why I was getting error here. For this particular part, when I did not mention the column, it goes smoothly because we are extracting all the columns. But here I'm specifically mentioning I need only these columns. So you have to use loc. When I do loc and run it, you can get the output. So here if you just validate quickly, every data point you see here has value more than 100,000. That's fine. Now you said that's fine that we could able to filter it out. That's well and good. Now I would like to filter it further with other columns, and let us see what all columns are available in DF. So we have employment, this, that. Let us go to a country column. Where is that? Okay, let us see. Fastly glance through currency. Here is the country. So we will take one column country. Second, we will take currency. Okay, now let me print these two columns also in the output, and later we will apply some condition on these two columns or one of the columns. So here I'm saying with this thing I need country also. So now I got country and the salary of individuals in this particular data frame as an output. Now suppose you would like to filter it. Suppose you would like to see people from India. You would like to filter just the people from India, or let us say United States of America. So now we will add this condition which says that salary is more than 100,000 and the people should belong to India or United States. So let me do that. For that thing, let me create a different one more filter which says country filter equal to, what I'm saying is, here I'm saying with df country dot is in. So what I'm saying, just validate this particular part and give me the true false as an output. Let me execute and show it to you. So I'm printing country filter here. If I get the output now, see, you are getting a true false as an output. Now my requirement says that I need a country, a people who belongs to these two countries, and salary more than 100,000. So we are using here the end condition. So let me do it for you. So in Python here we use ampersand as end, and we use pipe operator, which is nothing but this is the pipe operator for or. So we are in this particular situation we are supposed to use and. We are saying country India or United States and high salary should be greater than 100,000. So if I run here, you see that I got certain output here. So let me first show it individually, so we'll get more clarity how AND operator is working behind the screens. Now if you see the AND, so first value is true or false, second from index 1 to 4 is true, then 5 is false. Let us see after applying this thing what's an output. You can see the 1 to 4 should be true, but here the fourth one is false. Why it's false? Because if I print, let me print country again, country filter again. If I print country filter, you can see the fourth element here is false, and fourth element in high salary is true. So in the AND operator, if it's true and false, the output is always false. If it's false and true, output is false. If it's true and true, then only the output is true. So that's how the AND operator works. If you don't know, I think you got a basic intuition how AND operator works. So now I'm saying country filter, high salary filter. I can combine it and use it. So if I scroll down here, if I use it here, it means I should get where the country is either India or US, and the salary should be greater than 100,000. And here I would like to print the currency also. Now if you see the output here, the countries, if you see the countries, either it's United States or India. So now we have filtered a people whose salary is more than 100,000 and they belong to either India or United States of America. So this is how we can use the filters, and you can make more complex filters to filter your data further. So here I just use a very basic, it's not very complex. You can see the second level of complexity. You can do a lot of conditions here and put and get the output. So that's how you can apply the filters, and you can increase the complexity. You can use the complex logic to filter the data. So you can use the complex logic to get the required output. And in the description, I will give you a couple of coding exercises. So please go to the description to do those coding exercises. It will help you to enhance your skills. So in the next video, we will go ahead with the other available methods in Pandas. Till then, I am Vivek signing off. Bye bye.